Times where we're at the grocery store or buying something somewhere, and we need to do a little bit of addition or subtraction in our heads, and the only tools we have are our head. So mental math, doing math in your head. Now, that means not using your fingers, not using paper and pencil, and not using a calculator. So we want to work on how we can do that easier in our head. So if you think about it, when we work with units of 10, that's really easy. You know, I give you these problems, 10 plus 8, well, most people can say, oh yeah, that's 18. 20 plus 4, oh yeah, that's 24. Or 50 plus 6 is 56. 110 plus 3, it's 113. And the main reason we can do that in our head so easily is because these are all factors 10. Now if I ask you, what's 11 plus 7, I'm not saying you can't figure it out, but it might be a little slower to figure out than 10 plus 8. Or if I say 17 plus 7, again, you might be able to do it in your head, but it's going to be slower than just 20 plus 4, even though both of them equal 24. So this is an important point, that 10s are easy. So if we can, we need to use that advantage. So for example, let's say you were told 9 plus 6. So kind of in your head, what you need to do is be able to break this into pieces. Believe it or not, what I'm really trying to do is take a problem and make it simpler. So for example, I need to think in terms of 10s. So if I have 9, I know that's just 1 away from 10. So it's easy to think, okay, well 9 plus 1 is 10. So let me move that out of the way. Move this over, and then I know that this has become 10, and because I took 1 away from here, this is now 5. So 9 plus 6 may not be real fast in your head, but 10 plus 5 we know is 15. It's really simple when you do it in terms of tens. So we know we needed 1 from the 6 to make 9 a 10. That left us 5, so we had 10 plus 5. So the trick I'm trying to show you is sometimes you need to break a number down into pieces. So really, it's easier to think, okay, I had 9, I need to add 6 to it. Well, 6 is really just 1 plus 5. Well, 9 plus 1, I know is 10. 10 plus 5 is 15. So breaking it down into simpler problems is part of what we're trying to do. Let's try this next one. Let's say we had 19 plus 4. So again, it's easier to work in terms of tens, so 19 is really close to 20. So if I just take my 4 and break it down into a 1 and a 3, because that's still 4, I can take the 1 and add it to 19, and that makes this, so it's 20, and this, so it's 3, and I know 20 plus 3 is 23. And that may be easier to work in our heads than 19 and 4. So again, we got to think about 4 in terms of its pieces. It's a 1 and a 3. And that allowed us to do that in our head a little better. Okay, 49 plus 8. Again, we want to change this, if we can, to be in terms of a power or a multiple of 10. So I'm going to look at my 8 and really consider it to be a 1 and a 7. We got 1 too many there. Oh well, move it over. 1 and an 8. So 8 is the same as 1 and 7. So I'm going to take the 1, move it over here, which gives us a 50. Gives this to be just a 7 because we took 1 away from it. So we get 50 plus 7, which we can do easily in our heads, as 57. So we're trying to break down the pieces so that we can change this into a nice round number and then add what's left over. And the examples I've done so far have all ended in 9, because I think that's a little simpler because we just got to break 1 off to make it go. So let's look at one where it doesn't end in a 9, like 17 plus 7. You can really still use the exact same method, the exact same strategy here. So I want to make 17 become 20 because it's easier to deal with those multiples of 10. So what I'm going to do, grab the wrong thing, is I'm going to break 7 up. So it's 3 units plus 4 units. That's still 7. But I'm going to take the 3 and move it over here so that now I'm up to 20. So I've borrowed 3 from the 7, making it 4, get into the 17, and made it 20. So 17 plus 7 may not come to my head real easy, but 20 plus 4 is just 24. So again, I took 3 from the 7 and moved it over here to make this 20, and then added the 4 that were still left over. So it's really almost like I changed this into 2 simpler addition problems. It was 17 plus 7, but then I broke up the 7 into a 3 and a 4. Now this is still equal to 7, so it's still the same problem. What that allowed me to do, 17 plus 3 is 20, plus the 4, and just in general, this is much easier to do in our heads than this is. I've been doing math for a long time, and the truth is, mentally, I kind of am doing this in my head when I'm trying to work stuff out in my head. Okay, next up, 56 plus 6. So we need to think, okay, what do I need to add to 56 to bring it up to 60? Well, I need, sorry about that. Stand by, we're going to fix a little problem. Alright, okay, I think we're good now. Okay, so 56, we want to think, okay, what do I need to add to it to bring it up to 60? Well, I need 4. So I'm going to take my 6 and break it up to be a 4 and a 2. Because if I take 4 and add it to the 56, it becomes 60. So now that I have this as 60, by borrowing 4 from here, this is down to 2. 60 plus 2 is just 62. So by breaking the 6 down into pieces that were easier to work with, this was easier. Instead of having to figure out 56 plus 6 in my head, I just had to do 60 plus 2. Because I took 4 from the 6 and brought it over here to make it 60. Just a few more. Now this one, I want to show another trick when you're doing 2 that have 2 digits. So instead of just adding whatever to 1 digit, we've got 2 problems, or 2 questions with 2 digits. Again, breaking it down into simpler problems is a good way to make it work better in your head. So 12 plus 12 may or may not come in your head real quick what it is. So what I recommend is break up the 12. Sorry, I'm using the wrong button here. Break up the 12 into 10 and 2. Break up the 12 into 10 and 2. Because breaking this down into simple problems helps us. Because 12 plus 12 may or may not come quick in your head, but if you remember that 12 is the same as 10 plus 2, then you can just add the 10s together, that's 20, add the 2's together, that's 4, and we get 24. So when we have two two-digit numbers, we break it down by looking at how many 10s we have and how many single-digit ones basically we have. So we split the 12 into 10 and 2, split this 12 into 10 and 2, added the 10s together to get 20, added the 2's together to get 4, and that gave us 24. We'll try 2 more of those and then we'll be done. So same idea here, 23 and 51. That may not come in our head real quick. So the easier way to do it is to break it down and say, okay, 23 is the same as 20 plus 3. 51 is just 50 plus 1. So that allows me to, instead of doing 23 and 51, do some simpler problems and say, okay, this is 20 right here. This is 50 right here. And 20 plus 50 is 70. This is 3 right here. This is 1 right here. 3 plus 1 is 4. So this in total gives us 74. So by breaking this into two pieces, and breaking this into two pieces, where we have those factors of 10, or multiples of 10 that make it easier for us to work with, we're able to do a bigger problem in our head. Alright, a little bit bigger one. 139 plus 22. So 139 is the same as 130 plus 9. 22 is the same as 20 and 2. So this is 130, this whole big block here, plus 20. Okay, that's a little easier to do in our heads. 130 plus 20 is 150. And then we have 9 down here, and 2 here. 9 plus 2 is 11. Now, you might be able to do that in your head just fine, but if that still seems too complicated, then break the 11 down to be a 10 and a 1. So 150 plus 10 is 160, plus 1 is 161. So we just added two relatively large numbers in our head because we broke it down into simpler pieces. I think I may have one more. Nope, that is it. So that's the strategy you can use to help yourself do mental math better by breaking the problems down into simpler pieces.